Consider the function x cubed plus 3x squared minus 9x plus 10. Answer the following questions using calculus. That means don't just graph this function and answer. Use calculus. Find the intervals on which f is increasing or decreasing. Okay, for that we need to find the critical numbers. That means the x values where the derivative is 0. So let's find the derivative first. And the derivative is of x cubed is 3x squared plus 6x minus 9. Now we set the derivative 0 and solve for x. Those are the critical numbers, and we know that critical numbers are the numbers where the function gets local maximum or minimum. So that equals 0. 3, 6, 9. 3 can be factored out from all three. So 3x squared, 3 goes twice, 3 goes 3 times equals 0. And we can divide both sides by 3. So this factor 3 has no value anyways. We can ignore. And let's factor this trinomial. So x 3 is 3 times 1 3 and 1 make 2, so plus 2, so plus 3 minus 1. So from this we get x equals negative 3, x equals 1. Okay, so these are the critical numbers, and we know the domain of this function being polynomial, that's all real numbers. So we need to consider negative infinity through positive infinity, and negative 3 is a critical number here, and 1. Now we want to test these three intervals. We take a representative from each interval. So let's take any number here, negative 4. Let's take 0 and 2. Now we plug this value into the derivative, which is here. Okay, 3x squared plus 6x minus 9. Then let's plug in 0 because that's easy. If you plug in 0, 0 is negative, so the derivative is negative. Plug in negative 4, 3 times negative 4 is squared, 1648, so this will be positive. Plug in 3 as 2, doesn't matter, 2, 3, 5, and here we get positive. And we know that when the derivative is positive, the function is increasing. Derivative negative means decreasing on this interval, increasing again. So the answer is now f is increasing on negative infinity through negative 3 and 1 through infinity, and decreasing here on negative 3 through 1. Okay. Next we need to find the local maximum and local minimum at, look at negative 3. On the left the function is going up, increasing, then decreasing. So increasing then decreasing means we have local maximum at negative 3. At 1 the function is decreasing then increases, decreasing and then increasing. So at 1 we get local minimum at 1, and those are the only two candidates. I mean, those are the critical numbers. Okay, and next move to the second part of this question, in fact different question. Consider the function 2x cubed minus 3x squared, and we need to answer a couple of questions. First, find the intervals on which the concavity, where f is concave up, concave down. So concavity refers to second derivative of a function. So let's find the second derivative. First derivative is 6x squared minus 6x. Second derivative is now 12x minus 6. Okay. Now we repeat the procedure like we did earlier on the previous question. We set the second derivative 0 and find the x values. Those x values are the candidates for inflection points, x values of inflection points. Okay, just the candidates. So second derivative is here, 12x minus 6 equals 0. Move 6 over, that means add 6 both sides, divide by 12, so 1/2. So this is the candidate for inflection point of it. Okay, just the inflection, x value of inflection point. Now for the function, this is a polynomial, so the domain is all real numbers, and 1/2 somewhere here. Now we have two intervals to test. We just test the sign of second derivative. Second derivative is here, by the way, 12x minus 6, 1/2. So we can pick, let's say, don't have to write, but 0, x equals 1. If we plug in 0 here, 0 minus 6 negative, second derivative negative, that means the function is concave down. Okay, concave down. X equals 1, plug in 1 here, 12 minus 6 positive. So this is positive, means concave up. Okay, the function is concave up. So the function is concave up on 1/2 through infinity, concave down on negative infinity through 1/2. And it says find the x coordinates of the inflection points. At 1/2, look at the left of 1/2. We have concave down, and on the right of 1/2 is concave up. So the concavity changes at 1/2, concave down to concave up. So this is the x coordinate of inflection point. So 1/2, just the x value. If you want to find the inflection point, that would be 1/2 comma, plug in 1/2 here into the function, but that is not asked. Final